Suppose we have classes for different types of shapes. For example, rectangle, square, triangle, etc. All those shape classes likely to have methods to compute arrow or circumsphere. It would be nice to have a generic shape class to help organize those classes. Shape class should have method arrow or circumspheres in common, but shape cannot implement those methods because it does not know how to calculate the arrow, because shape does not really represent any specific shape. That's why we should make shape class as an abstract class. And circles, square, triangle are subclasses of shape class. All these subclasses must implement the arrow method or to be abstract. Each of these methods are implemented differently in different subclasses. Once we create the shape class, we could create a shape class array to store all different types of shapes. For example, array index 0 is used to store circle object. Array index 1 is used to point to rectangle object, so on. An arrow method can be invoked for shape references, even though shape does not define a body of that method, because shape defines them as abstract. This is an example of polymorphism. Checklist class. We call this class is an abstract class which has one concrete method. Is this class an abstract class? This class does not have an abstract method. What are the rules for abstract class? If a class has one or more abstract methods, then that class must be declared as abstract class. If one class does not have abstract method, if you want, you still can define that class as abstract class by putting keyword abstract in the friend of class. We cannot use abstract class to create objects. Abstract forces the class to be subclassed. If a subclass of an abstract class does not implement all of the abstract methods inside, then that subclass must be declared as abstract. A Java interface is a collection of abstract methods and constraints. An interface is to use to establish as a formal contract or define a set of methods that a class will implement. For example, here, interface doable defines a set of abstract methods. Do this, do that, so on. Because all methods in the interface are abstract, so we don't need to put abstract keyword before the method name. An interface can also contain data members. All data members are static, final. All methods are abstract. All methods are public by default. We cannot have keywords native, static before the method names. We cannot use interface to create object. But any class can implement one or more interfaces. A class formally implements an interface by stating so in the class header, providing implementation for each abstract method defined in the interface. Of course, a class that implements an interface can be final or abstract, just like any other class. A class can implement an interface as well as extending another class. Here, class can do implements doable by providing the body of those two methods or other abstract methods defined inside the interface. A class that implements an interface can implement other extra methods as well. In addition to those abstract methods, an interface can contain constraints or data members. When a class implements an interface, it gains access to all its constraints or methods. Many things class implements two interfaces, interface 1, interface 2. What are the differences between abstract class and an interface? We can only inherit one abstract class or normal class, but we can implement many interfaces. Abstract class can have concrete methods, but interface cannot. All data members in interface are public and static, but they're not true for abstract class. Abstract class can have constructors, but interface cannot. Abstract class can have final, no final, static, no static data members, but interface can only have static, final data members.